Wait, a white dwarf is shooting across the galaxy. It is a type of star, and scientists at the University of Warwick have discovered one moving very fast through the Milky Way. Boris Gaensicke is Professor of Physics and Astrophysics at the University of Warwick. Good morning, Professor.
Good morning.
Imagine people who've never heard of a white dwarf before. What are they and where does the name come from?
So the white dwarfs are the burned out cores of stars like the sun that are left behind once the stars run out of fuel. And they're called white because they're initially extremely hot, and so our eyes would perceive them as white stars if we could see them from closer.
And what's special about this one?
So this one was discovered in 2015 already and stood out as being a bit of an unusual maverick. And we did a more detailed study and found that it has a combined set of observations that made it initially very difficult to explain. It moves extremely fast, 900,000 kilometers per hour. It has extremely weird chemical abundances with not atmosphere or made of oxygen and neon and magnesium and silicon, which we usually wouldn't see in a white dwarf. And it has a very low mass. And so that took us quite a while to figure out how that star acquired these properties.
And what do you think now?
So we came to the conclusion that the only way we can explain its properties is that it underwent a supernova explosion, which is a well-known and kind of long-studied process. But in the past, it was usually assumed that in a supernova, the star is totally destroyed and nothing's left behind. But it's now becoming clear that some types of supernovae leave a partially burned star behind and give it a bit of a kick so that it then moves across our Milky Way.
So this one is still burning then and still moving, but is it taking longer to burn out than you would expect?
It actually stopped burning probably 40 million years ago, but it is still moderately hot, so it keeps cooling down from when it stopped burning, and it keeps the velocity it had at the moment when it was ejected, and so will keep traveling with that very large velocity for the time being.
And why is that important?
So supernovae have a very, very big role in our understanding of the universe as a whole, because we can use a specific type of supernova to measure distances across the universe. And that has been used those were tools that were used to discover that the universe is largely made up of something we call dark energy, and that physicists still argue about what it actually is. And despite the fact that these tools are extremely important, we still don't really understand why and under what conditions these supernovae happen. And usually we see them in galaxies that are far away, and we have no idea about what star exploded and why. So having a star in our backyard where we can say for sure this underwent an explosion, and we can look in great detail at what effect that explosion had on it, that will help us to understand the supernovae as a whole class and their use as tools for cosmology.
Professor Boris Gaensicke, thank you very much.